Welcome back to another HVAC-Engineering-Techie training video. Today's lesson is on HVAC technical commissioning pre-functional tests. This video will actually walk you through how to do pre-functional tests and how to actually create the check sheets to do that. So remember, this is a channel that talks all things HVAC, from engineering design, construction, equipment, systems, test and balance, controls, efficiency, and performance. So before we start, I'd like to ask you again to be a subscribing member. Please hit the subscribe button down below. Give me a thumbs up for this video if you like it. That doesn't cost you anything. It's absolutely free to you. It was painless, but it really helps me because Google uses that to evaluate my videos and actually keeps me on the air. So I would really appreciate it if you do that. If you haven't already, if you have already, I really appreciate it. Thank you. Let's get started. Thanks. So now we'll start talking about pre-functional tests. What's the difference for pre-functional tests? Process commissioning provides commissioning management of contractors for creating and performing PFT check sheets and contractors completing the PFT forms. Technical CX normally creates the PFT check sheets and also provides commissioning management for contractors on performing PFT tests and completing PFT forms. Some CX providers may actually perform the PFT test and forms. Some CX providers may actually perform the PFT test and forms in an effort to get them done in a timely manner and to provide more value to the owner. It's a little bit of work. So when I first started, we did that. We don't do that anymore because we spend our time browbeating the contractors to get that done. PFT tests. The first type of pre-functional tests are inspections of installed systems to verify they are installed correctly and that the systems are ready for startup and automatic operations. The second type of PFT test is a startup test of the equipment or systems. These check sheets capture the startup data, set points, electric volts and amps, and key system parameters. Once all systems have been started up, it verifies the systems are ready to be tested and balanced. Once tab is complete and all control programming and testing is complete, then the systems are ready for functional testing. What is a PFT check sheet? HVAC check sheets, a pre-functional test check sheets, are normally created by the commissioning team for each piece of equipment or system of the scope of work. The first type of PFT check sheets for installation verification are to verify that the equipment or system is installed in the correct location, is installed correctly, normally completed by the installing contractor. So when you write up these test sheets, you want to make sure that you have enough data in there, and it's like a pilot's checklist. The contractor goes through and says, yep, I've done that, I've verified that, yep, this is what it is, here's the model number, I verified that. And they collect all the data that you want him to collect. Some commissioners actually don't do any of this. They have the contractor create the check sheets and go out and check it in the field. And, you know, in philosophy, if the control contractor's number one ambition was the quality of the install and the functionality of the system, that would actually work, but it doesn't happen that way. Remember that the contractors have other priorities, and that is profit and meet the schedule. Those are big. Those two are huge. And your requirement is he's not judged on anything that you're judging. If the system doesn't actually work, it's not his problem. And so they will take care of the things you ask them to normally, but it's not their priority. And you got to understand that they have other priorities, so you need to figure it out. So I think sometimes I'll tell a contractor, if you have a system already in place and you're really used to using it, give it to me and let me look at it. And if they're sufficient, we can use those. 90% of the time I've done that, they're inadequate. They're not adequate at all. They don't collect the right data. They're not intense enough. So we just make it easier. We provide them with everything. It's so much easier to do it that way. The second type of PFT check sheet is for verifying that the equipment or system has been started up correctly, normally completed by the startup contractor. No problem. And we provide that startup data sheet. We're not trying to take the place of a manufacturer startup requirement, but what we are trying to do is gather a bunch of data. So we ask for the startup data to be in the sheet, and we explain to the contractors how to collect the data and what the data should look like. So in other words, if it's a 480 volt motor on an air handler, we don't want the report saying, yeah, it's a 48 volt motor. No, we want to see 3 amp readings and 3 voltage readings for that 3-phase 480 volt motor. The reason is we need that data if we end up having to do any energy calculations on this motor, and we want to make sure it's correct. If we get the voltages back and there's 15 to 20% difference in the phases, something's wrong. We want to know that exact data. We want to know the fan suction pressure, discharge pressure, all that stuff that's happening during startup we want to see. And if you don't have it in your check sheets, you're never going to get it. As a matter of fact, even if you have it in there, you might not get it, at least not on the first round. Check sheets are created from the design documents and approved submittals, shop drawings, and manufacturer's installation instructions. The data they give you, the submittal data they give you, and the O&M manual they give you, has all this stuff in there. I mean, they give it enough so the contractors know how to do this stuff. This is a check sheet again. This is off an old company of mine, so nothing secret about it. What these look like is immaterial, and whether they're on paper or whether they're in a cloud-based system, that makes no difference. It's the data we're trying to get. So this is a check sheet we've created, and it has here the test information. This is when we're going to do the test. This is what it is. This is the equipment installation. This is the checklist. This is the things we want the contractor to check. This is the design data, or submittal data. This is the data that's on the submittal. And what we normally do is have the, if like we're saying this air handler is modeled such and such, what we want him to do over here, the verification data, this is the field data, to actually put the real model number. Because a lot of times the model is an A-53, but really it's A53465849. But we want to have the whole data off the tag, off the label data. And then if you have some issues down here, we want to see the actual data on that. Issues and progress notes down here, and a verifier signature. That's important because we want to explain to the contractors that we don't retype these. We put these in the report as you give them to us. So if they look terrible, they don't have data, they're sloppy, well then that shows what a quality contractor you are. I don't want you to type them, but I'd like them to be legible. And then this is the verification note over here. So this is the data, and this is any note complements we might want to have here. It's really simple, no problem. There's a little bit of an issue. These seem like this can be done all at the same time, but maybe sometimes they're not. Sometimes you go to a site and you use a check sheet as a contractor, and some things are not done, so you can't complete the sheet. That's why the cloud-based sheets are actually better, because then you can look at it or someone else can look at it later, and online they see what you've done and they can add to it. So that makes the online systems better. The only problem with the online systems is a lot of them force the contractor to a pre-built list, which is not good, because every project is unique and should have unique check sheets for it. This again is a startup check sheet, and again it has the test information over here, the date, stuff that did that. It has the checklist. This is everything that's going to be checked in the startup. Now this is not telling the guy how to start it up. It's just collecting the data at different stages in the startup or for different components in the startup. It's asking for that data. Again, this is the submittal data. If it was supposed to be 29 amps, that's what will go here. But over here, we want to see the exact 3 measurements on the 3 legs for the amps it actually had. Field data or mark verified. That's another thing. We normally ask a contractor to tell us that he checked that and he verified it. There's a lot of things that seem logical that aren't. We ask them not to use check marks. We ask them not to say okay, because I don't know what that means. The check mark may mean I've tested it, may mean I'm going to test it. It may mean it failed. It may mean they could mean all kinds of things. I want words that have meaning. So basically you verified it or you didn't verify it. Did it work or didn't it work? If it didn't work, there needs to be notes down here what you're doing to fix it. And of course, this is the issued and progress notes, and this is the verified signature. Verifier signature is important because I want somebody to be proud of this thing, and I want to know who did it. So we need to have verifiers on it, not just do it. A lot of contractors treat these check sheets as make work, and they're not. They're documentation of what actually went on. This one can be very important to an owner. If something happens 10 years down the road and he looks at it and he said, what did it look like when it was first started up? You go to this document and you can see, well, here's the data we had. You can see if it's changed. It's very, very helpful. Okay, for controls PFT test, what's different? Process commissioning normally relies on the control contractor to provide all test sheets and to perform all installation and startup sheets. Most process guys say the controls, he's the expert at that. We don't offer any value here, so we're not doing it. We're just going to look at what he gives us. Technical commissioning normally creates the PFT check sheets and also provides commissioning management for the control contractor on performing the PFT tests and comparing PFT forms, completing PFT forms. CX providers may actually perform the PFT tests and forms in an effort to get them done in a timely manner. This is a little harder for control. We normally have them do it and observe them, but remember, we're doing another point-to-point test anyway. So this becomes less important to us because we're doing that. Technical CX will always perform a separate point-to-point test, even if the control contractor has already performed their own test. Now, we say, well, why would you do that? Well, having been a control contractor, and I thought it was a good one, is what happens is a control programmer or technician in the field will spend a lot of time working on the first prototype controller and program. Get out there and he'll test it, make sure that works. Okay, now it's working. Okay, guys, so take this piece of software and add it to the other 100 just like this one. They don't ever test it. They just load them in. Say, well, it worked there, so it's going to work here. There's too many variables. It's just not going to happen. So a lot of times they don't provide actually good function, even though they should. Control system PFT check sheets. Pre-functional tests PFT check sheet for control systems are normally created by the commissioning team for each control panel. Our test sheets are all done by control panel. Now, a control panel may have 3 or 4 controllers in it. It's not done by controller, it's done by panel. The first type of control PFT check sheets for installation verification are to verify that the control panels, controllers, and all control devices are installed in the correct locations and are installed correctly, normally completed by the control contractor. The second type of control PFT check sheet is for the verification that the control system is ready for operation by performing a system point-to-point test. Sometimes the control contractor's test is actually a loop check, where they're checking all their loops to make sure the polarity is correct, they're testing the right device. That's really good. That's good stuff. But our point-to-point testing is somewhat different. Check sheets are created from the design documents and proof submittals. Shop drawings are manufacturing installation instructions. And here's an installation check sheet for a control installation. And again, it's just like the other one. It has the test information up here, has a checklist, and these are pretty simple. Is the room sensor installed? Is the duct sensor installed? And all this is an installation check, so it's just, are they all installed? And then you go through and say, verified, 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 and you put a note saying, this one's in, but it ain't in correctly, so we need to make an issue log item, that item. This is submitted data. This is field data or mark verified. And this is the progress notes, and that's the verified signature. So this is a control PFT, and these are always filled out by the control contractor. We can fill them out, but normally we don't. This is a same sheet, but it's in different form. You'll notice that this one is one piece of paper per controller. This one is one piece of paper for many controllers. And these are done for simple controllers like VAV boxes or fan coil controllers, something that they have a lot of points. And in this case, this is the test information. This is the checklist right across the top. So these work because they have a small checklist. The others have a big checklist, so they mean a piece of paper. And what this one does, it makes many less forms and check sheets. Now, on a cloud-based system, maybe it doesn't matter, but if you're a paper-based system, this matters. This is the unit number, submittal data, field data or verification all across the sheet. This is progress notes or issue notes, and verified signature again. So this, if you're on a paper-based system, this kind of form works well. So control system verification point-to-point tests. They're done after the control contractor completed his loop checks and has been tested the system for correct operability and completed all graphic programming. Okay, so this is something that's really important. We're going to do now a commissioning control system verification. So control guy's done. Now we're going to come in and verify as a commissioner the system's ready. To do this, we need the control graphics done. So it unfortunately, From the time DDC was invented till just last couple of years ago, and sometimes still happens, the habit of the control contractor was build a job, and then once the job was done, he would start on the graphics. And he would tell the owner, well, it's going to take me a while to do the graphics, so you'll have them by the time you're fully moved in, or get used to it. And sometimes 3 or 4 months after the building was occupied, they didn't have control graphics. So what we did to combat that, we actually told, in our process, we asked for copies of each typical graphic in the control submittals. So when you submit a control submittal, you need to have a copy of every unique graphic that you're going to put on this job in the graphic. And it's very wise to do that. So this way, the owner can check the graphic and say, yep, that's what I need to control this job. The engineer can say, yeah, that looks like controls, and you as a commissioner can check it. And then the control contractor is good shape. When he doesn't do that, and he does it all on his own with no approval, and he does 400 VAV boxes, and the owner looks at it and says, well, I don't like this. I like this done differently. Now he's got 400 of them to change. It's a foolish place to be, but it can be. By having them put the graphic plates in the submittal, you now have sped up the graphic process completion, because we need them done before we start to do our point-to-point. So it's really important they be done. Now, they don't have to be 100% done. They have to be so that we can see every point and we can override every point that's overridable. That's really important. They can, maybe they don't have a floor plan, fancy graph done. We don't care. As long as somewhere we can see the room temperature, room humidity, and everything else, and we can deal with that. So they actually need to be done. This actually would make a control contractor a whole bunch of money if you do this regularly. The commissioning point-to-point test is done by the CXP, the control contractor, and the owner's operators. It's really important to try to get the owner's operators there to help. Not only does it save you a manpower to do that, but also it's a training event for them. It's really valuable for them to see all the systems, see where the points are, see what the problems were, what they weren't, because actually they need to do these point-to-points in the future when they're maintaining their system. We used to sell a lot of maintenance contracts, and in that maintenance contract was an annual point-to-point and calibration event. Verifies each control point is installed correctly and functions correctly from the end device to the graphic point. So we do this, we do it from the end device, clear back to the screen, and we verify, because there's a bunch of opportunities to actually misassign the graphic point to the actual controller point. So it is possible to have the graphic, say it's air handler 4, it's actually looking at the supply air temperature on air handler 5. It's possible to do that. So we want to make sure we do go to the graphic. Verifies graphic pages operation and completeness for the required control functions. Verifies all controlling sensors, temperature, pressure, flow, humidity, CO2, and others are properly calibrated. This is where the most work comes in. The point-to-point is really pretty easy. You can blow through them really quick. But the calibration of the sensors is really important and takes some time. And this is where this separates us from the other people and from what the control contractor does himself. I have never seen a control contractor actually calibrated sensors. And if he does, he's using an uncalibrated instrument, which makes it useless. Verify valve and damper actuator ranging. So we need to verify that the actuators are ranged correctly. Completed prior to functional performance testing. We can't functional test until this is done. If you try to do a functional test without this, then you're going to have a lot of issues with your functional testing, and it'll take you time to figure out why, and it'll come right back to what you should have found in point-to-point testing. This is a control point check sheet. Now, these are a little different. This is the point-to-point test. So basically it has the test information. It has the manual test and results. So we all have some manual tests up like here, like prove it went on and off and things like that. Prove it was staged correctly. And then we have the checklist of things we want them to check. And then this is the analog point test data. This is the binary point test data. And this is the progress and the notes down here. And of course it verifies signature. Now what happens up here is this is the digital points. And this is on and off verification. So you verified it went on, you verified it went closed, you verified that it turned on or turned off. And these are the analog points. And this you're going to say that this was the value we seen in the field with the calibrated instrument. This is the value of the screen set. And this is the offset. And out here we'll pick a note. We actually put an offset in the controller. So this is a very handy device of information for the future operation of the system. These are the startup sheets. This takes time. And this is the same thing done in linear form. So here you've got the test information, the unit number, and then over here you have the checklist of what you want to check. And here you have the analog point test data, and here you have the binary point test data. It does the same thing as the other sheet, but this does a whole bunch of controllers. These are normally used for VAV boxes and terminal units. The other form are used for air handlers and central plants and that kind of thing. There's the notes, and here's the verified signatures. All right, so that's pre-functional tests, kind of a warp through that time. There's nothing secret or difficult about those check sheets. This is the tedious part of this job. I hope you got something out of that. Appreciate you watching the video. Appreciate you being a subscribing member. Have a great day, and I'll catch you on the next one. Thanks.